Hey everyone, today we're looking at section 2.7 homework part 2. So we're going to start working with rational expression inequalities, figuring out when these things are positive, zero, negative, undefined, things like that. So this first one, number 43, we're like, hey, when is this thing positive? Well, what I like to do is the only time you can possibly change from positive to negative or vice versa is at an x-intercept or a vertical asymptote. So those are the numbers I'm going to list out on a number line here. I'm going to say, okay, so I have -3. I'm going to list them out in order. -3 and 4, dash, 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 dash. Here's my function value. I'm like, okay, so I have an x-intercept at 4, so the function equals 0 there. But I have a vertical asymptote at -3, so that's going to be no good there. So I don't want to include that in the overall set. I'll include this if it's greater than or equal to 0, but I'm not going to include the vertical asymptote. So if the only possible place you can change from positive to negative is at an x-intercept or vertical asymptote, that means I just need to check each of these buckets, check one point, check the sign of that value. I don't even need the value, just the sign of it. And if it's positive, everything in that bucket's positive. So I'm going to check a number to the left of -3, like -100. That would make numerator negative, denominator negative. And so if I took a negative and divided by another negative number, I'm going to get a positive. If I check a number between -3 and 4, like 0, that would make the numerator negative and denominator positive. So negative and positive. A negative divided by a positive is a negative. If I check a number to the right of 4, like 100, if I plug that into my numerator, I get a positive number. Divided by another positive number is a positive number. So if I want to know when this rational expression is positive, when is it greater than 0, it's here, everything to the left of -3, and here, everything to the right of 4. So parentheses, -infinity to -3, union 4 to infinity, and it'd be parentheses on both of those because I'm not including. Let's check 55 here. So this is kind of goofy because it's like, hey, when is this rational expression less than 2? I have no idea. So what I'm going to do is I'm going to subtract 2 and try to figure out when this thing is negative. So that's a little easier game to play. So I need to get a common denominator because this would be tough to do if just this with a shift. I don't know. That'd be kind of goofy. So what I'm going to do is I'm going to multiply this 2 by x plus 3 over x plus 3. And if I do that, I would get x plus 1 over x plus 3 minus 2 times x plus 3 over x plus 3. I have the same denominator, and I can add those numerators together. If I distribute that -2 across this parenthesis here, I'm going to get x plus 1 minus 2x minus 6, which simplifies to minus x minus 5. And if you want, I'm going to kind of write that as negative parentheses x plus 5 over x plus 3. And I want to know when is that negative? So I'm going to do a little sign chart here. Start out with my little number line. So -5, -3, dash, 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 function value. Okay, so let's see. This function equals 0 at -5 and doesn't exist. It's got a vertical asymptote at -3. So if I check a number to the left of -5, like -100, and keep into account this negative here, so that's like a negative in front with a -100, that would be negative, and that would be negative, and all of that together would be negative value. Check a number between -5 and -3, like -4 would be a negative. That would be positive, and that would be negative. So that would actually be positive if I multiplied and divided all that together. Check a number to the right of -3, like 0 or 100. It would be that negative on the outside, but then that's a positive and that's a positive. So the result would be a negative. So looking at this here, when is this thing less than 0? Everything to the left of -5 and everything to the right of -3. So the solution set is -infinity to -5, parentheses, union, -3 to infinity. Here is 60. Kind of the same idea. Hey, when is this rational expression greater or equal to 2? I don't have any idea. So what I'm going to do is I'm going to subtract this 2 to the other side. And this would be kind of goofy too, because when is this with a shift? I don't want to play that game. So I'm going to get a common denominator to get all of this together to figure out when this is greater or equal to 0. And that'll be the same solution set for when this is greater or equal to 2 because of legal algebra. So if I'm looking here, I need to get a common denominator. So I'm seeing this, I'm going to multiply this 2 by x plus 2 over x plus 2. And I don't like this negative kind of sitting out there. So I'm just going to write it as plus a negative, just so I kind of keep track of it. So now I have a common denominator. Add my numerators, x minus 2x minus 4, all over the common x plus 2, which would simplify to negative x minus 4 over x plus 2. Okay, so if I factor that negative out, again, I like writing it like this, over x plus 2. I want to know, when is this greater or equal to 0? So I create my little number line here, negative 4, negative 2, dash, 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 dash. Let's put some function values here. So we have an x-intercept here. That makes it equal to 0, undefined here. Okay, so in this one, I got to be careful because I am including the 0. So I want to make sure to include the zeros, but not the vertical asymptotes. Okay, so check a number to the left of negative 4, like negative 100, would be a negative, negative, negative. That's going to be negative. Between negative 4 and negative 2, like negative 3, this would be negative, positive, negative. So let me do that under negative, positive, negative. All that together would be positive. And number to the right of negative 2, like positive 100 or 0. So if I put in a positive 100, that's negative, that's positive, which is going to give you a negative. So looking at this little chart here, I noticed that this rational expression is positive in between negative 4 and negative 2. And I'm going to include that negative 4. So it's going to be bracket negative 4, comma, negative 2, parentheses. And I am done. Okay, so 67, kind of another goofy question here. When is this rational expression greater than this rational expression? I don't know. That seems like a crazy question. So what I'm going to do is I'm going to bring everything over to the left. I'm going to subtract this entire rational expression, 3 over x minus 2. Again, you can't multiply both sides by x minus 2 because the variable can flip the inequality. So I have to work and do some legal algebra where I'm not multiplying or dividing both sides by a variable. Okay, so then if I switch this over, I'm going to have this over here, and I'm going to get a common denominator. So I'm going to multiply this by x minus 2 over x minus 2. I'm going to multiply this by x plus 3 over x plus 3 to get that common denominator. And again, I don't like this kind of minus sitting here, so I'm going to kind of write that as plus. I don't like that sitting out there. I usually lose track of it. So now I have a common denominator. So I'm going to distribute this, 3x minus 6. I'm going to distribute this, minus 3x minus 9. And if you notice, the 3x's cancel out, leaving you with minus 15 over this. And I want to know, for some reason, this flipped. So I'm just going to keep these signs the same. This is greater than, and this is greater than. Okay, so I want to know when this thing is greater than 0. Well, the numerator, this rational expression, doesn't have any x-intercepts because it's just a negative 15 up there. That never equals 0. But it does have 2 vertical asymptotes. So those are possible places where I can change sign from positive to negative or vice versa. So I'm going to list those out. But both of those are bad. I'm not going to include those in the set, even though I'm not including the zeros. It's just greater than. Okay, so I'm going to plug a number into this right here, like negative 100, negative, negative, negative is negative. A number between negative 3 and 2, like 0, negative, positive, negative, negative, positive, negative is positive. A number to the right of 2, like 100, negative, positive, positive is going to be a negative. So looking at my chart, if I want to know when this is greater than 0, it's just between negative 3 and 2. So that should be my solution set. Again, I don't need to do all this crazy checking the physical value between negative 3 and 2. There's my solution set there. And if you want to use the set builder notation, it's the set of all x. Vertical line means such that negative 3 less than x less than 2, squiggly bracket. So interval notation within the set builder notation. Or just use the inequality notation in the set builder notation, or just use the interval notation, your call. All right, 2 more. Okay, for the 69, again, first thing I'm going to do is just factor this. So I'm going to get, if I factor the numerator, I'm going to get x squared minus, x, I'm not going to have x squared. I'm going to have x minus 2, x plus 1 on top. And below, I'm going to have x minus 3, x minus 1. So getting this all nice and factored, and I want to know when is this greater than 0. Okay, so if I make my little sign chart here, list out all of those values from left to right. See if I can list them all here. So I have negative 1, 1, 2, 3, dash, 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 function values. Okay, so let's see. 1 is going to be an x vertical asymptote. 3 is a vertical asymptote. Negative 1 is an x-intercept, and 2 is an x-intercept. Okay, so let's check a number to the left of negative 1, like negative 100. Negative, 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 negative. So if I took a negative, 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 that's all going to be positive. If you multiplied the sign of all of those together. A number between negative 1 and 1, like 0, negative, positive, negative, negative. So let's write that out. Negative, positive, negative, negative. If you took all of those signed numbers, multiplied and divided them, you'd wind up with a negative. Let's check 1.5 on this interval. So 1.5 is negative, positive. Let's see, this one's good. There's too much of this. So this is negative 1.5. That make that positive. That's still negative there, and that would be positive. So that overall would be positive there. Let's check 2.5. So if I check 2.5, this is positive, positive, negative, positive. So that would be negative there. Then if I check to the right of 3, like 100, positive, 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 is going to be a positive. So looking at all these intervals here, if I want to know when this thing is positive, when is this thing greater than 0, it's to the left of negative 1, between 1 and 2, and to the right of 3. To the left of negative 1, parentheses, negative infinity to negative 1, union between 1 and 2, parentheses 1 to 2, union, and to the right of 3, parentheses, 3 to infinity. Or here's the set builder notation. The set of all x such that, vertical I mean such that, x less than negative 1, or 1 less than x less than 2, or x greater than 3. All right, last problem. When is this rational expression less than or equal to this rational expression? I don't know. That's the craziest question I've ever seen. But what I'm going to do is I'm going to add this whole thing to the other side. And I'm going to play the plus minus game. When is all of this less than or equal to 0? Let's get a common denominator. These both have a 4. This has an x plus 2, and this has an x minus 2. So this thing on the left needs an x minus 2 over x minus 2. And this one on the right needs an x plus 2 over x plus 2. So if you do that, you get 1 times x minus 2, which is just x minus 2. And this would be 3 times the x plus the 2. And then my denominator, I would have 4 times x minus 2 times x plus 2. If for some reason multiply that out already. Okay, so here's my two fractions with my common denominator. And then I can distribute this 3x plus 6 here. And then common denominator, add my numerators, combine like terms, and then I can cancel out those 4s to get this. And again, I would leave this one as 4. Oh, that 4 is gone. As x plus 1 over, because these 4's cancel out here. So I'm going to look down here. Over, and I'm going to leave this as in nice vectored form. X minus 2, x plus 2. And now I want to know when is this less than or equal to 0. Okay, so I'll make my little sign chart here. I got x values. So I have negative 2. I have negative 1, and I have 2. Dash, 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 function values. So I have two vertical asymptotes there, and I have an x-intercept at negative 1. Okay, so if I check a number to the left of negative 2, like negative 100, I get negative, 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 is going to be a negative. Between -2 and -1, like -1.5, that numerator will be negative. That's negative, but that's positive. So it's going to be positive. Between -1 and 2, like 0, positive, negative, positive is negative. And then to the right of 2, like 100, positive, positive, positive is going to be positive. So I want to know, when is this negative? That is to the left of -2 and between -1 and 2. So to the left of -2, parentheses, negative infinity to -2, and then union between 1 and 2. And since you want less than or equal to 0, you're going to include the -1, bracket -1, but then 2 parentheses. And then there's your set builder notation. If you want to write an interval notation or set builder notation with the inequality notation on the inside, the set of all x such that x less than -2 or -1 less than or equal to x less than 2. So I want that -1, but I don't want the 2. So hopefully you had fun today, and I will see you next time in class. Take care, everybody.